A very warm welcome to everyone here. I'm Xavier, the chairperson of the Cambridge University Astronomical Society. Tonight, we move away from astrophysical theories and experiments to something more human. We are very honored to have Professor Dame Jocelyn Bell Burnell with us to give a talk titled A Celebration of Women in Astronomy. Before we begin, please allow me to share a little more about our speaker. Professor Dame Jocelyn Bell Burnell, DBE, is an astrophysicist. She was responsible for the discovery of pulsars while a radio astronomy graduate student in Cambridge, and has subsequently worked in gamma ray, X-ray, infrared, and millimetre wavelength astronomy. She currently holds a Professorial Fellowship in Mansfield College, University of Oxford, and is a visiting academic in the university's Department of Physics. She was awarded the Michael Faraday Prize in 2010 and a Royal Medal in 2015 by the Royal Society, and also holds major awards from French, Spanish, and USA bodies. A member of 7 academies worldwide, she was the first female president of the Royal Society of Edinburgh, as well as of the Institute of Physics. She is currently Chancellor of the University of Dundee and was previously a Pro-Vice Chancellor of Trinity College, Dublin. She holds numerous honorary doctorates. Now, without further ado, Professor Dame Jocelyn Bell Burnell, please.
Thank you very much. Am I heard?
Yep, that's great.
Good, thank you very much. And I believe you can see my screen.
Yes.
For the invitation for this evening. I'm sorry it can't be in person. I do enjoy visiting Cambridge and reminding myself of my time there as a PhD student. However, needs must, and thank goodness for Zoom. I'm going to talk a bit about 3 women astronomers. None of them are with us now. And then I'm going to talk a bit about the position of women in astronomy worldwide today. The women I'm going to talk about in chronological order are Caroline Herschel, Cecilia Payne-Gaposchkin, Vera Rubin, and then a bit more about women in astronomy in general. Excuse me. So Caroline Herschel was a German woman. She was born in 1750 in Hanover. She lived almost to be 100, and she spent quite a bit of that time in the United Kingdom, as I will describe. The family she was born into in Hanover were military musicians. Her father and several of her brothers played instruments for the military. Her mother, by contrast, could not read or write and didn't really see why girls needed an education. Caroline, in fact, was her amanuensis, reading and writing letters for her. Caroline had severe illness as a young woman. I think it was typhus, indeed even as a child, and was advised by her father that she should not expect to get married. She was neither rich nor beautiful. Her role in life would be to be a housekeeper for one of her brothers. And indeed, she became housekeeper for one of her brothers in Germany. He sounds a pretty poisonous character. She wanted to learn French. Could she have French classes? No, no need for French. She wanted to have dressmaking classes. Yes, provided everything you make, Caroline, is clothes for me, your brother. So she got her dressmaking classes, but I don't know that it benefited her very much. It was much better for him. One of her older brothers, William, had moved to Bath. This is Bath, England. He was earning his living both as a conductor and as a composer. And he wanted Caroline to come to Bath to be his housekeeper. He also wanted her because she had a nice singing voice, and he thought she might well complement his musical events. The rather nasty brother back in Germany agreed, provided William paid the cost of a servant for him so that Caroline could be released to go to Bath. So women were really the equivalent of servants. Now, at about this time, elder brother William became interested in astronomy, and in particular in making his own mirrors for his own telescopes. And music was getting rather less of his attention. But Caroline came to Bath. She performed some concerts with him, singing soprano. She was rather shy. She would only perform if it was William who was conducting. The pair of them lived in this house in Bath for about 10 years. It's quite a tiny house. This is its frontage. That, I think, is a scooter or a motorbike with a cover over it, just to give you an idea of scale. It goes right through to a garden at the back, and it's got 4 floors, sorry, and I think also a basement. But it wasn't very big. It has been turned into a museum about the Herschels. So if you ever come to Bath, I'd recommend a visit to it. It's really interesting. Out the back, there is a green plaque on the back wall of the house. You can just about see it there in this photograph from the garden. And it says, here lived scientist and musician Sir William Herschel, 1738 to 1822, from where he found the planet Uranus, March the 13th, 1781. He also discovered infrared radiation in 1800, and his sister, Caroline Herschel, early woman scientist, 1750 to 1848, hunter of comets. So Caroline increasingly became William's assistant. When he was making mirrors, grinding mirrors, she would feed him his meals, forkful by forkful, so that he could continue grinding. And she got really rather annoyed because all his cravats got spattered with pitch, and that's extremely hard to get rid of from a cravat. And with the mirrors as he'd made them, William observed. I don't think he really understood the science of mirrors. He just made lots of different ones and worked with the ones that were best. But it was from here that he discovered the planet Uranus, indeed. Caroline was his assistant when he was observing. She would sit nearby, but with a small table and a little lamp, and William would yell out the coordinates that he wanted recorded, and she'd write them down in the little book. She'd spend quite a lot of her night observing with William. William occasionally had to go away on business, and he gave Caroline a small telescope so that she could observe the skies herself. It was a telescope with quite a large angular field, so she was surveying quite a chunk of the sky at each sweep. She really knew the night sky quite well by then, because working as William's assistant and recording his data, she'd learnt a lot about the sky. And she did, as the plaque says, discover some comets. Then King George II, who was the reigning monarch at that time, came originally from Hanover, where the Herschels came from. William is invited to become the King's astronomer by King William II. I'm getting really muddled. And they move to Slough, near Windsor, actually on the bank of the Thames. And Caroline goes too, and she assists with the observing each night. She reduces the observations. She prepares the material for publication. She teaches herself geometry and calculus by quizzing William over breakfast after a night's observing. And also during the day, she runs the house. She can't have got a lot of sleep. Occasionally, the royal family, when they had some visitors they didn't know what to do with, and this happens even to monarchs as well, they call for a coach and they drive their guests round to the Herschel's place to be shown the telescopes. And if William was away on business, Caroline did the showing. And it was apparently extremely clear that she knew exactly what was what and how things worked. And she gave very well-informed tours to these royal visitors. Their visitors' book reads like a who's who. It was quite an amazing range of visitors. Some years later, the king also gave her a small stipend. So she becomes Britain's first paid female scientist and arguably also Britain's first civil servant. And it's going back a bit. I don't know that the king was intending to do either of those, but he just thought she deserved some money, I think. Using the telescope that William had given her for looking for comets, she found a total of 8 comets. These photographs are of a fairly recent comet, Comet Hale-Bopp, the last really good one we had in this country. Very attractive objects and quite unlike stars. And the right-hand photograph is particularly good because it shows you that a comet has 2 tails. There's a fainter blue one going up at a steeper angle, and then the one showing the whitish tail that is what we expect from a comet. So Caroline made her own name finding these comets. She got recognition late in life. At age 7, when she was 78, the Royal Astronomical Society gave her a gold medal. At age 87, the Royal Irish Academy made her a member. And she went back to Germany when William married. I think she felt a bit redundant. I think she also felt actually that was a bad move, but she was stuck in Germany. And on her 96th birthday, the King of Prussia gave her a gold medal. So she got recognition, but certainly came very late in life. The next woman I want to talk about was born Cecilia Payne, married and became Cecilia Payne-Gaposchkin. Her father worked in Oxford. He was a fellow in one of the colleges. I don't know which. And at that time, fellows weren't allowed to marry. He finally decided he did want to marry, so he resigned his fellowship. And he was quite old when Cecilia was born in 1900. He died when she was still a small child and the family moved to London. She had an aunt who was a botanist and she became quite interested in botany herself and decided that that's what she'd like to do. But apparently at school, she was at St. Paul's Girls' School in London. At school, she was also very good at music. And the music teacher said she could be a professional violinist. Now, the music teacher that we're talking about at St. Paul's, this is shortly after the First World War, or maybe even in the First World War. His name was Gustav Holst. You'll know the name. He probably knew what he was talking about when he said she could be a professional violinist, but she was set on being a scientist. But there was a deviation in her track. I'll skip ahead and tell you a bit about this deviation. She got a place in Newnham College. Some of you, I'm sure, will recognize these photographs. She got a place at Newnham to read botany. But just before the end of her first term, there was a big lecture to be held in Cambridge, ticketed, to be held in Trinity. And a good friend of hers had got a ticket, but in the end couldn't go, and gave her the ticket. So she goes along to this lecture in Trinity. It's a lecture by Arthur Stanley Eddington. He has been abroad making observations of stars during a solar eclipse to confirm or otherwise Einstein's theories, particularly about his prediction about the bending of light. Eddington is an extremely good speaker, makes things very, very clear. And of course, Einstein was a bit the rage. So was Einstein right or was Einstein wrong? So a lot of people wanted to go and hear Eddington talk about what he'd found. He'd found that Einstein was right, incidentally. And this talk was about the eclipse expedition and how they verified Einstein's prediction. And Cecilia Payne-Gaposchkin was transfixed. She said she went back to her room in Newnham and could write down the lecture word for word, almost exactly as he gave it, with all the data right. Eddington subsequently published that lecture and she checked her account against his published version and she had got it absolutely right. She didn't sleep for several nights. She was so caught up in all this. And she decided she wasn't going to do botany, she was going to do physics. And she told the university authorities. Now, you all probably know it's not quite that simple to change course in Cambridge. But she was pretty persuasive and very determined. And for the rest of her time in Cambridge, she was doing physics, natural philosophy, mathematics, and doing a bit of astronomy with Eddington. I think maybe project work rather than coursework there. So she got to know Eddington quite well. She got a good degree and wanted to do a PhD, and Eddington told her not to stay in Britain. It was too stuffy. She'd never get on as a woman. She should go to the USA. So as a newly minted Cambridge graduate, she got herself on a steamer, took herself to Harvard, or actually not quite Harvard, and did a PhD there. At that time, Harvard didn't really take women. It had an offshoot called Radcliffe College, where they parked the women. So Cecilia Payne-Gaposchkin was really the first female grad student, but technically she was in Radcliffe rather than in Harvard. And her project was to study the spectrum of the sun, a nice bright object for doing astronomy on, determine what chemical elements were present. It was firmly believed that the sun and the earth were made of the same stuff, so people kind of knew what answer she should get. And she didn't get it. She showed that the sun was mainly hydrogen. And nobody would believe her. And she produced her data for them, and they still weren't absolutely sure. She published the paper, ultimately, a good paper, showing that the sun is mainly hydrogen. She stayed on at Harvard afterwards. In fact, she stayed at Harvard for the rest of her life. At one point, she married Sergei Gaposchkin, who was a Russian emigre, I think maybe even a refugee to some extent. And they lived in or around Cambridge, Massachusetts. But for a very long time, she did not have a proper job, a proper paid, named job. Indeed, she was paid out of the equipment budget, and her office was a broom cupboard. So inside the broom cupboard was her desk, and she sat at this desk with the broom cupboard door open. She ultimately was made head of department, and at that point they decided they'd perhaps better get a proper post for her, and they did. But she had considerable trouble initially getting people to believe that the sun was made of hydrogen. Ultimately, of course, we did have to believe it, and indeed most other stars are made mainly of hydrogen. So this is the Harvard College Observatory. It's rather earlier than when she was there, but it's a very fine building. Right, so that's Cecilia Payne-Gaposchkin and the spectrum of the sun and the composition of the sun. I want to turn now to dark matter and the rotation of the galaxies. And I'm going to talk about a US astronomer called Vera Rubin, who died not so many years ago. Very interesting woman, absolutely determined to be an astronomer. Being married and having 3 or 4 kids was not much of an obstacle. She did have a very supportive husband, but she too had some trouble getting jobs. And actually, she too had trouble getting her observational data believed. Just a reminder about Kepler's third law. It's usually taught in terms of planets going around the sun and how the gravitational attraction between the 2 bodies balances the centrifugal force. And so if you make a plot of the orbital speed v squared against 1 over r, you get this, no, against r, the plot is, sorry, you get this, what they call a Keplerian curve. That's true for any planet orbiting any sun or any small body orbiting a large mass. Galaxies have large mass at their centers, so the material outside the center of a galaxy should orbit at the speeds given by this formula as well. And Vera was studying galaxies and how they rotate. Now, this would be a hard galaxy for her to do because it's almost face on and the rotation is all in the plane of the paper. But if the galaxy is tilted at all, you can get Doppler shifts on the spectral stars and get the motion, and also probably on the gas between the stars as well. So galaxies tend to have a hub, and if it's a spiral galaxy, they've got these lovely spiral arms. There are also elliptical galaxies where it's much more homogeneous and it's just sort of elliptical. But again, as long as it's not face on, you can probably get rotation curves for it as well. You can see how fast it's rotating. There are lots and lots of spiral galaxies, and they make for very, very pretty photographs. And I think it was spiral galaxies that Vera Rubin first started studying. And she made a plot of the velocity against the radius. And right at the center, of course, the hub, the real hub is pretty stationary. But as you move out a bit, you begin to get linear velocities. And the velocity grows, and then it kind of sort of plateaus. But as you get towards the edge of the galaxy, the outer bits of the galaxy are rotating in the same way as planets rotate around the sun. They should follow that same Keplerian curve. So the rotation velocity should drop gradually, coming down to 0 somewhere away off to the right. And Vera's curves didn't drop. They kept going on straight or straight-ish for millions and millions and millions of light years away from the hub. And it was so unexpected, she had real trouble getting people to believe her. Why wasn't she seeing this when she got to the edge of the visible galaxy? The answer is there must be, beyond the visible galaxy, some dark material that is part of the galaxy and rotating with it, which means you haven't yet reached the edge of the galaxy by here. And indeed, Vera was showing you hadn't reached it by here either, or by here, or by here. You have to go out a very long way to find the real edge of the galaxy and see the rotational velocity scooping down towards 0. But whatever this stuff is, it doesn't shine. And this was the first indication that there is this stuff that we call dark matter. In a galaxy, as well as all the visible stuff, and the not quite visible stuff contains genuine dark stuff, dark matter, which contributes to the gravity. So this was the first hint of what we now spend quite a lot of time studying, dark matter. There was further evidence for it, which helped Vera's case. This is an image of a cluster of galaxies. There's a big sort of group of them in the middle. It looks a bit like a B or something, doesn't it? But it's actually 1, 2, 3, 4 big galaxies and lots of little ones, and lots and lots and lots of other galaxies. And some curious arcs here, round here again. Indeed, it's maybe even a double arc. Yeah, there might be another bit over here, and here's a bit as well. So what is all this? Well, right beyond this cluster of galaxies, indeed beyond the center of this clusters of galaxies, there is a quasar, and the light from it is rather bluer. And this group of galaxies plus their dark matter act as a kind of lens and refocus the light in these arcs. And the size of the arcs determines how much mass there is within them, and you have to include the dark matter to get the right answer. So this lens image was further proof that there was dark matter associated with galaxies, and also confirming that it was in the kind of quantities that Vera was getting. So today we believe that our universe has a whole load of dark energy, not to be confused with dark matter, that there's dark matter that I've just been talking about, and there's the visible stuff. And the visible stuff takes up just 5% of the mass energy. The dark matter that Vera first discovered occupies about 27%. And then there's a whole lot of dark energy as well, even more. So about 2/3 is yet another unknown. So we more or less understand 5% of the universe, and the rest we're still working on. So as they say, watch this space. So those are some notable women, I feel: Caroline Herschel, Vera Rubin, Cecilia Payne-Gaposchkin. How are women in astronomy doing today? Well, like every story so far, this is a bit of a mixed story. Aha, okay, sorry, something's gone slightly wrong with my slides. A group of women around about 1990 wrote to the International Astronomical Union. This is the world body for astronomers. And this group of women, they were mainly British. They were concerned about the dearth of women in astronomy, and could the IAU help maybe study this topic? The then General Secretary of the IAU was a University of London guy called Derek McNally. And Derek didn't want to touch this topic. So the woman who wrote to him got a fairly short reply. The IAU sees the status of women in astronomy as essentially a social issue. The IAU regards itself as a body devoted to the promotion of astronomical science, and to this extent has tried not to cross the line into matters of social concern. Full stop. And there the matter rested, at least as far as the IAU is concerned, until some years later, when Johannes Anderson, who died just last year, was General Secretary between 1997 and 2000. Johannes was a Danish astronomer, and he'd always been pretty lucky. He'd had good jobs in Denmark. But his wife, Birgitte, had tremendous trouble getting jobs in astronomy in Denmark. And Johannes wondered if it was because she was a woman, and then realized that he had data that might help answer that question. Because as General Secretary, Johannes keeps the membership data for the IAU. And the IAU not only has the country astronomical bodies, the national astronomical bodies as members, it also has individual astronomers as members. and he started recording this membership data segregated by gender. Now, he only knew of two genders, male and female, and the IAU hasn't moved away from that yet. But starting before the 2000, he started recording this membership data. So this is a subset of the data as of June last year. I've looked at countries which have more than 200 astronomers, and then I've looked at the breakdown of each country's membership into male and female. And I've listed them in order of decreasing female fraction. So the country in the world in 2020 that had the highest fraction of astronomers female is Italy with 28%. France 26, Brazil 23, Spain 22, Russian Federation 21. Russia's always had, well, always, for a long time had a tradition of women working because they lost a lot of men in the First World War and in the flu epidemic that followed straight afterwards. And the women had to go to work and the state had to provide good nurseries for the children, good care. Now, over the whole of the IAU, the world average is that 19% of astronomers are female. The Netherlands is bang on 19, Australia 18. Here comes a whole lot of English speaking ones. USA 17, Canada 16, India 14, China 13, Germany quite low, but Germany has not often been that kind to its women. Here's the UK, and there's Japan. It's perhaps not surprising Japan is low down the list. The UK used to be higher up the list, up with the other English-speaking countries. The UK hasn't been paying attention to this, and we've slipped rather badly. I hope we're going to unslip quite quickly. It's quite an interesting pattern. Europe, South America, doing very well. Northern Europe, not so well. The English-speaking countries, below the world average. USA has by far the largest contingent, so it pulls the average towards itself. Germany traditionally has been low, Japan traditionally has been low. But what might cause this kind of pattern? Why are Southern European countries high and Northern European countries low, for example? The membership is, well, I've just changed it actually, but it has been for tenured astronomers. So larger numbers of young women weren't counted. They have now introduced a younger astronomer membership, and there are a good proportion of women in that younger cohort now. To become a member, you have to be nominated by your country's professional body, and that might apply some kind of filter in some countries. If anybody wants to follow this up, the data is available, at least the current year is always available, and it makes very interesting reading and thinking about. So what might be the cultural factors? Well, it could be that men don't see astronomy as a serious subject and they're elsewhere, leaving astronomy for the women. Or it might be in that country, the parents still live near the young couple and they're very happy to help with the child minding, releasing the young mother to go back to being an astronomer. Or maybe they live in a country where there are lots of poor people, people who'd be only too happy to come into your house, be your housekeeper, your cook, your cleaner, your childminder, your laundry maid, etc., 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 releasing you, female, the wife, to go back to work and be an astronomer. I don't know if these guesses are right, and I'm not sure which apply where, but these are the kind of things I could see happening in some cultures and not in others. Physics and maths organizations, world organizations, don't collect the data in the same way, but they feel that there is a similar effect that what the astronomers see. But it can't be that women's brains in different parts of the world are different. It must be cultural factors, attitudes in the country and that kind of thing. Just a few minutes about what's been happening in UK universities addressing equality. First of all, we've started collecting data on our academic workforce, how many women, how many men there are at each level. It shows that in science, particularly in the physical sciences, women are in a minority, and the minority gets more minor the higher the level you go up. It also shows that women progress more slowly than their male counterparts. This may be because they don't present as well in a male-dominated world, or it might be the effects of child-minding responsibilities. I think we're all aware that following COVID lockdowns, in a household where there are children, it's the woman of the house who has more often helped the children with their schoolwork, their homework, than the man in the house. But the data also show that women were putting in fewer grant applications and were less willing to apply for jobs. So in Britain, we decided we needed to fix the women. We had to make the women braver, more willing to put in grant applications, to apply for promotion, to apply for jobs. And for a while, we ran special training courses to help women address these deficiencies. But that assumes that it is women that are deficient. It assumes the problem is with the women, and there's absolutely no problem, thank you very much, with the way society and the way science are run. Indeed, for a while, we had special fellowship, special funding for women, returner fellowships for coming back after a career break to have children, and other things that were open to women only. And then we found that some charming gentlemen would say, you only got that position because you're a woman. You're not up to the standard of the rest of us. You should leave. This did actually happen. So now these kinds of funding are open to both men and women. And the woman, if she gets it, can say, I won it in open competition. But also the funding agencies began to realize that giving help to those individual women, whilst it helps them, doesn't change anything structural or anything in society. And they began to look for what they call institutional change, making the workplace fairer for everybody. So some examples of institutional change. The individuals running a university may not be discriminating, but the structures might be. There can be institutional sexism, possible biases in recruitment, retention. Maybe only one macho management style is considered proper. And there's also unconscious bias. Now, down the bottom, if you can see it, I've got an example of unconscious bias. Can anybody see what the bias might be there? This comes from a form where you're asked to indicate which sex or gender you are. It's actually only giving 2 options. It ought to give more, but it's giving 2, M for male and F for female. Well, the unconscious bias is those are not in alphabetical order. Why does the M come before the F? It carries the hidden message that the male is more important than the female. That's an example of unconscious bias, and you can still find it. And I have great fun returning forms saying, your form shows unconscious bias. I'm not going to fill it out until you correct that. And a few days later comes a plaintive little email. We're very sorry. We can't see any unconscious bias. Could you tell us where it is? I won't be able to do that too much longer. They're all getting wise to it. And finally, there is a quite well-known US company studies businesses, studies what makes businesses successful, promotes good practice. And they've shown that companies that have the most diverse, gender diverse, ethnicity diverse, executive and board, those diverse companies are more robust, more flexible, and more successful than companies that are less diverse. So diversity matters. Diversity makes a difference. And we need to learn how to do it and do it well. I don't know how it is for younger women today, but certainly when I was a young woman, there was a sense of being pushed in certain directions by society's expectations. I would have children. I would be a stay-at-home wife and mother. And it's quite insidious. It's quite hard to recognize. And it begs the question of who should we listen to and where can we get unbiased guidance on what our strengths are. And on that rather ambiguous note, I'll finish. Thank you for your interest. Thank you for your attention. And I hope maybe there's time for some questions, but back to you, Chair. Thank you very much.
Right. Thank you so much, Professor Dame Jocelyn Bell Burnell, for the wonderful talk. So we have some time for questions right now. If anyone would like to ask a question, you can put it in the chat, or if you prefer, you can also raise your hands using the Zoom function. To start off with a question from Kate Tana, asking, why isn't it surprising that Japan has low female representation in astronomy?
Sorry, so why isn't it
surprising that Japan has low female representation?
Right. Japan traditionally has been a very masculine society. The women are have been rarely seen outside the house. So that's been absolutely the norm in Japan until very, very recently. And Japan has quite a lot of catching up to do. It is beginning to catch up, but there are very, very few female Japanese astronomers, for example. I can only think of one at the moment, but I think there's maybe 2 or 3 in the whole country.
Right. We also have a question from Nick. Did you have any female role models in your career?
No, there weren't any female role models for me. When I was at university, we had briefly one female physics lecturer, but she left pretty quickly. The atmosphere was really rather hostile to females. There was one female in maths, a lecturer. None in geology that I remember, one in chemistry. Very, very few.
All right, we have a question from Kat Lidham. As students in astrophysics, what can we do to help with the situation?
Yes, that's a nice question. Thank you very much. I think it's important that if you're in an area where there are not so many women, that you behave sensibly, responsibly, and do your best work, because to some extent the chances for women to follow you will depend on what you've been like to teach, what you've been like to work with. So I'm afraid, as wherever women are in a minority, those minority women really have to be super women. Astrophysics is actually rather better than physics. And I think the really big issue is, why aren't there more women in physics? And since physics is a school subject, maybe we need to be asking what's influencing gender choice, the choice of subjects, the different genders at school. A lot of the physics teachers in schools are male, so the women will lack role models. And if you were prepared to go back to your old school or other schools in your hometown and talk to fifth form, sixth forms. Sorry, I don't know the right year numbers, old-fashioned language. Talk to some of the GCSE and senior classes. Tell them what it's like to be an astronomer, and see maybe if you can convince some more girls that actually it's would be very good for them. I think it's lots of little actions like that, but also making sure that there actually is no bias, to be honest, to make sure that school teachers are genuinely unbiased, to make sure that university admission tutors are genuinely unbiased. I think, talking to the ones I know, they're actually keen to get as many girls as they can. So maybe it's at school, top end of school, that the constriction on the supply chain is. I'm not sure. But also to try and convince the general public that science is a great field for girls to be in, all kinds of science. So that there's plenty that we can do.
Right. So we have Kate Tana who's raised her hand. If you don't mind unmuting yourself to ask your question.
Yeah, thank you. I think I can speak now. Hi, Dr. Burnell. It's like a great pleasure to hear you speak, and also like this very important presentation. I actually do like women's and non-binary representation work at the Cambridge Union, and I reached out to you over email, but never heard back. But it's still good to see you in some form nonetheless. I think my question is around something you mentioned earlier, which was that earlier, like the problem was seen in women, like they're not confident enough, they're not applying enough, and like they're really not putting themselves out there. But then actually the issue is more structural in nature. In my personal work, and like I'm not in like physics or astrophysics, I'm actually in like development studies, but in kind of the work I do in society, let's say, like I hear that a lot, like I'll see a lot of like well-minded people, like really friend, like who want to see women's advancement in different areas, say things like that, right? And it's like I'm kind of always in this conundrum where I can engage in a discussion about how the problem is structural, but then I would kind of not get anywhere because they wouldn't agree. Whereas, if I do agree with them and say, oh, you know what, yeah, that's right, women do need to be more confident, and here's what you can do to help them feel more confident. And so like, I've kind of framed myself that way at times to get things done. And I guess I was just wondering, like how that's possibly played out in your life, like if you had any suggestions for people working to improve gender representation in any area and dealing with attitudes like that.
The really firm way to deal with some of these issues is if you can get numbers. How many women at this level, at that level? How many men? How fast are the women rising? How fast are the men rising? People can't argue with data. But of course, there are sometimes places where there isn't data or the data is debatable. What has happened, I think, usefully in Britain is that the funding agencies, the people who give universities money for research or for running the university, have been taking an interest in the gender balance in the student body, in the senior leadership body, everywhere. And once the people who provide the money begin to take that issue seriously, everybody has to. Until that happens, progress will be slower, I think, inevitably. Or arguably, if the funders are putting pressure on, maybe the progress is too fast for the society. I'm not quite sure which is the right argument there. But also, I worry slightly when it's perceived that the women are deficient. The women aren't putting themselves out there enough, blah, 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 blah. Why should they? Why should they have to? Why do the women have to operate on the male norms? Now, these are big, big questions for society. And I'm not quite sure how we're going to sort them in the long run. But it's worth just watching what is being assumed, you know, like it's important that women learn to put themselves out there. Maybe it's not. Or maybe it is the way our society runs at the moment, but should our society run that way at the moment? Etc., etc. Does that help? Thank you.
All right, so we also have Anushka who's raised his or her hands. So would you like to unmute yourself to ask a question?
Hi, hello. Thank you so much for your talk. It's been fantastic to hear you today. A real privilege. And I guess my question aligns with one of the anecdotes you mentioned about how in a lot of programs where there's a targeted outreach to increase women's participation or improve representation in certain areas and certain fields, there can be backlash of, oh, well, you only got this because you're a woman. You're not actually talented enough to compete with the rest of us. And I noticed those same themes arising in matters of race when it comes to affirmative action for racial representation as well. What is your response to such, because I've always found it difficult, kind of similar to Kate, I found it difficult to know what to say to people in these situations, because whilst of course representation is so important, how do you counter that argument?
I think you have to say something like the university or whoever it is has a rigorous selection process and many different factors count. Race or gender will be one of them, but it's only one of many, many factors, which is actually true. It may have been just enough to nudge you ahead of another candidate, but okay, that's fine. It's not that it's really swung the selection. Indeed, there is a curious spin-off from some of this. A number of female postdocs around Oxford in science subjects are saying, we are getting a lot of interviews for jobs. Maybe it's postdoctoral positions or something, but we think they've got no intention of appointing us. They've called us to interview because they want to show that the slate they interviewed has got gender balance. So there are all sorts of places where things can go wobbly.
All right, we have time for maybe one more question. So if there are any questions. Right, I think that might have been it for tonight. So thank you all for coming tonight, and thank you so much again, Professor Burnell, for giving the talk. It was very inspiring and enlightening. So yep, that's it for tonight. Good night, everyone. Thank you.
Thank you. Good night, everybody.